Okay, let's have a little fun and see what we can do to try to improve the score. When randomized searches don't work, and by the way, they often are used to start, because when you have a really large data set, sometimes, just trying out a bunch of different hyperparameters that tend to limit overfitting can give you significant gains. Then the next approach would be to just continue to take them one hyperparameter at a time. So I'm going to copy that basic code we have up here, which produced the best score so far using an estimators of 400. Now, it wasn't that much better, so I'm going to maybe keep it at 100 just for speed and add in max features. So you're probably wondering, what is max features? Well, what max features does is it cuts down on the number of columns. Okay? If you look at the actual data, which is under this first RF model, like maybe year is not helpful. I don't know. Maybe, do we really need temperature and a temperature? Maybe not. Okay. The point here is that instead of us selecting them, max features will actually randomly select them. So we can only choose, say, half of the columns. Okay. That would be 0.5. We could choose 0.7. There's value to getting rid of even just one of them, like 0.9. And of course, you can always select those on your own. So that's just a quick, few. We can see if that does better than 1.0. It could be worth trying more since we're only going to do this one. Right? Okay, so let's see if any of these outperforms in previous score. And I guess if you're not sure with previous scores, you can always... So my understanding is that 1.0 would be everything. I think that should work. Okay, so it's going to check it, and then we'll see what it does. Shouldn't take too long, but note that I also up here, I pulled up, if you type in random forest regressor in Google, you should get the sklearn ensemble, and it will show you all the different hyperparameters, and it's going to tell you about them too, like max depth, for instance. And so we can find more, square root log 2. Sure, you can also just do it the way I did it, which is using percentages. Okay, so these are just standard ones that people try. Sometimes you have a lot of columns. Okay. All right. I guess auto might be the default there. Okay, let's see what we get. Look at that. We got the best score yet using half of the columns. Right? Pretty cool. Okay. Now, let's make a couple of other adjustments. Let's just see, okay, if little changes matter here. Okay, what if we go to we can go bigger or smaller. Let's change this. Okay, let's just double it. And it's interesting, so let's try 0.4 and 0.5. And maybe we'll change one more. If it's getting lower, but let's just start with this. Now this is going to build how many? It's going to build 4 models here because it's looking at, but this one is, these two are going to be twice as many trees. It's looking at combinations of taking, and you look, we got better with 200 estimators, and max features is 0.4. Wow, that's really interesting. And so what I want to do, maybe 200 will be a nice number for us, is does it matter now if I change this? Okay, if I go up or down a little? Well, let's find out. Okay, so I've only got 6 trees here. So what I'm doing is I'm trying to finesse just these 3. Okay, and seeing how these 3 can help to produce results. Max features is known as a strong hyperparameter for in estimators. You would think that all columns are gonna, be the best, but it's not necessarily true because, the models are trying hard to work with all the columns, and it could be that some of the columns only give you slight gains. We keep getting better, right? So we took a more shallow tree, and it still worked out. So we can try that again. Okay. We could go 10, 12, 14, and I'm just going to leave it. Well, I don't think we could try 0.3, but let's just try it like this first. So note the score too. It's 640.23. So we're seeing some significant gains here. And note that the grid search is checking all combinations. So it's checking max depth of 10 with max features of 0.4, max depth of 10 with max features of 0.5, and so on. And then if I only provide one option, like in estimators equals 200, of course it has that. Okay, so we did not improve that. So this is pretty strong now. Right, and so I'm putting that there because that's a current best. Okay, that's a current best right now. And I mean, it can be helpful to leave up what you actually search, because then you can get it lost. But you also could just keep doing it here. So what next? Well, there are different ways you can decide. I mean, you can go up here and like you could consider one. Like what else might work? I mean, it's hard like if you don't have any info. I did mention I would talk about bootstrapping. I think I may have before. It says, well, this is not clear in itself. OOB is its own thing. Random. Okay. Look back at the top here. We could consider max leaf nodes in best fashion, first best nodes. These are hard to like understand based on their descriptions. I will say that. The minimum samples for split and the minimum samples per leaf, I think, could be ones to look at. So the minimum samples for split basically tells you this is comparable to max depth, but it says, hey, we're not going to keep splitting, like just keep endlessly splitting here. The default of 2 would mean that, look, if you have 2 rows, okay, you've got 2 rows, you can split it and then you're going to get one of each. Those are going to lead to perfect predictions. Why? Because if at the very end of a tree, all you have are individual rows, you're going to correctly predict the score. But if you have to estimate between 5, that's different. So the idea was with min samples split, you're going to stop splitting once you reach a certain number of rows, and that's going to be then becomes the leaf then. So let's try that one. Okay. So min sample split, add it here. And again, the default is actually 2, okay? So, I mean, you can have 2, but you can also not, because it just did 2 to get the 640. So let's see if we can beat 640. And that's why it can be nice to actually have it up there. So, when I followed my own advice and put it down here and take this out. Well, you want to keep in the bracket. Okay, so because now I can see the score that I'm trying to beat. So I could try 3, 4, 5, 6, 8, 10. Okay. And again, if you wanted to expedite the process, you could cut down in estimators, but we'll go ahead and leave it. Okay, this shouldn't take too long. All right, so we're just seeing if we get a gain, right? Will stopping the splits prematurely allow us to do better? And it could be that, by the way, these don't actually have any effect based on the max depth, right? It's not really clear from this. But note that let's see. Yeah, it didn't improve. Okay. And the best it gave was 3, which is close to the default of 2. So it could be that, these other parameters, they're overtake sometimes like the others. Okay. So that doesn't really give us anything. Okay, so we can kind of safely ignore that. All right. And let's try one more. What we'll do, okay, I promise, once we get to XG boost, we're going to hit like a lot of them in depth. Okay. Min samples leaf is similar. Like how many are required to be at a leaf. We're getting one gives you perfect prediction, but we can say no, like we can basically use the same setup and say no, we're going to stop it if there's 5 because we want to average things, okay? So keep trying to click on the other one. And again, I will leave that one, but change it to, is it min samples leaf? Yep. Min samples leaf. And now again, the default is 1, so I think I want to put in a 2 here. Based on what I'm seeing before, I don't, well, you never know. It's cutting out a little bit for us. Okay. And by the way, well, here, let me do this first. What I want to say is that they do work in conjunction. So this approach is not guaranteed to give you the best results, right? Because we're stating, hey, max depth is 14, max feature is 0.4. Max features cuts out a lot, right? So it could be the case that increasing max features, it does not improve. Increasing max features will actually allow, min samples leaf to have a little more say. Just for instance, I don't know that this will help, but if, okay, what did I get? 2? So let's just say I tried 2, 3, and 4. How about 2, 4, and 6? And now I give max features a chance to be higher. Let's see, does that in fact, let's see, 658. Let's see, does it do better than 658? I mean, we have our top score above at 640, which I think is going to be tough to beat. Taking its little time here, right? You get the 200. And the other thing is that we can just start to increase in estimators. So yeah, this is not improving at all. Okay, so I think it's being taken care of. I just put in the original that we have. All right, so although note that the better score, well, we changed it. Okay, see, that's the other thing, right? It's not an option. This doesn't match this, so you can always run things again. But so far, the best score that we've had remains the 640.23. And again, you could try just improving in estimators, right? You can totally use this to run one model. Like I can say, well, okay, is more trees just going to be better? Let's find out. Can we crack 640? And because it's doing a grid search, right? I should say because it's doing cross validation, we did not, okay? The other one was saying 640, 641. And you could start to like wonder about, whoa, wait a minute, this could go on for a long time because we could try like 180 and like maybe 125, right? Like 175 and 225 and like, is there like a way around this? And well, it's just not perfect. Like there are little coding things you can do, Hey, we cracked it, right? 175. So a little less was a little better. And then again, once you have that information, you can say, okay, let me work with that. Like, why don't I try like a 150 here? Can I do better than 639? Try 165 even, right? You could also could be higher, 185. You can be, pretty nuanced, right? I mean, and again, with the random state here, do keep in mind that, so note that it's kind of the same, right? There were decimal places of difference. But when it's like that, take the one that's less, right? Take 150. Let's just compare these two. When you have the randomization in, right, because we're picking random state equals 2, look at that, 125 is better. And I think I'll leave it at that. It doesn't mean that this is guaranteed to be better. It could be that with another random state, 150 is better. So when you're dealing with like really slight differences, it doesn't mean it's necessarily better. That's my point. But certainly, like if a lower number of trees gives you a better score, then that's the one you want to try. But now also when you're changing these, right now we've been holding max depth steady. And this is where, right, there could be a little fun interplay between the two. So maybe just for a final one, I've seen good numbers with these. Now I don't want to do too many models, but like there's 9, right? And let's just have a little fun with it and see. Can we outperform 125 and 14? And if by the way we don't, we can feel pretty good about that as a good one. So what we've covered in this lesson, it's my hope is that you're getting a better feel for random forests in general. Random forests are strong when it comes to out of the gate getting good scores, right? And that's why it's been, yeah, we didn't improve it, so I feel good about what we got. Um, random forests are really strong out of the gate, meaning it's because they have the 100 decision trees and the randomization involved. It's fine tuning them takes more work. Okay, and it's because again they're so good to begin with. But we were able to get some gains of about 639. I think we started with what 670 or 80, something like 30 or 40 bike rentals, which is not insignificant. You could save a company a lot of money with that. And this is very intriguing. I think that it could be the case that we're looking at too many columns, right? So I will stop there. And this general process that we've been working on a little bit, which is, hey, I'm getting used to kind of how a new model works and then trying to like fine tune it on some data is going to be a continued theme. And then what we'll look at going forward, next lesson will be on gradient boosting. Okay. And we're going to start with timers using that. And we're going to use that as a lead into extreme gradient boosting, which is XGBoost. And so XGBoost and Random Forest are competitors because they're both ensemble methods and they both give great scores on average. XGBoost tends to do, it doesn't always, but like usually it does a little better by default, and also has, because it's gradient boosting, some more options on the fine tuning side. So we'll continue our practice of fine tuning and learning what these different, you know, hyperparameters mean, along with new ones that we haven't seen yet when we get into gradient boosting and extreme gradient boosting. Thanks.